Okay, so as in the last video we have discussed about the Heisenberg uncertainty principle, in which we got to know that we cannot determine the position of an electron and the momentum of an electron at a time. And this was the biggest defect or drawback of Neil Bohr atomic model, since he determined the position of an electron and the momentum of an electron at a time. As you can see this formula, uh, where he told about the position, r is equal to n square h square epsilon naught upon pi m z e square, right? So he told about the position of an electron in an atom, and he told about the velocity, or you can say momentum, of an electron as well. V is equal to z square upon 2h epsilon naught n. So he told both these points at a time, which could not be explained at a time according to the Heisenberg. He was a scientist. So this was the Heisenberg uncertainty principle, in which we cannot determine these both things, position of an electron and momentum of an electron at a time. And this we have discussed in the last video. In today's video we're going to start our next theory, which is all about Planck's quantum, right? So today we are going to start our Planck's quantum theory. Initially we'll be going with the basic introduction or general introduction to the Planck quantum theory, or Maxwell, what how does he started, or what did he do. So we're gonna look into it. Basically in 1900, this is most important. Wait, let me write this here. In 1900, Max Planck, and he was a German physicist. German physicist. German physicist Max Planck in 1900, German physicist Max Planck, he studied what? He studied the spectral lines. What did he study? He studied the spectral lines which were produced or obtained from the hot black body at different temperatures. Alright, so what did he study? He studied spectral lines which were of course obtained by what? These were obtained from hot body at different temperatures. From hot body at different temperatures. All right, different temperatures. All right, so let me highlight the point what I have written here right now. What did he study? In 1900, there was a German physicist, Max Planck. He studied spectral lines which were obtained from the hot body at different temperatures. These were obtained from the hot body at different temperatures. Alright, he studied spectral lines which were obtained from the hot body at different temperatures. What did he observe then? He observed that light radiation was produced discontinuously by the particles of the hot body. What did he observe? He observed radiations. All right, which were produced discontinuously continuously by the particles of the hot body all right. So what did he observe then? He observed the radiation which were produced discontinuously by the hot body, by the particles of the hot body, all right. So he observed the radiations which were produced discontinuously by the particles of the hot body, all right, which were vibrating with a specific frequency, and these particles were vibrating. These particles were vibrating with a specific frequency, all right. So he observed the radiations which were obtained from the hot body of the particles, and those particles were vibrating or accelerating. Now you know that what is mean by accelerating, which means the movement of back and fro, to or fro, back forth motion, all right, that is vibratory, or you can say that is acceleratory motion. So those particles were vibrating with a specific frequency, means the vibrations increase with an increase in temperature. If we increase the temperature, the vibrations in the particle were also increased. So the vibrations in the particle got increased as well. They both increased. All right. So when they increase the temperature of the particle, so the vibration of that particle also increased, all right. Thus Planck proposed a new theory, and that was known as Planck's quantum theory. He proposed a theory called Planck's quantum theory, right? Planck's quantum theory, all right. He proposed a theory which is known as, of course, the Planck's quantum theory. Now let me summarize this all, right. What I have taught till now is, in 1900 there was a German physicist named Max Planck. He studied spectral lines which were obtained from the hot body of the particle. What did he observe then? He observed the radiation which were produced discontinuously by those particles of the hot body. Those particles, by what he observed, the radiations which were produced discontinuously, those particles were vibrating, those particles were accelerating with the specific frequency, and when he increased the temperature, the vibration or the acceleration in the particles got increased as well. Thus at the end he proposed a theory which is also called Planck's quantum theory. In next video we're gonna discuss about the postulates of his theory, or the postulates of Planck's quantum theory. This was the general introduction to the Planck's quantum theory.